Hi guys, and welcome back to another lesson. In today's lesson we are going to be looking at doing experiments, and particularly through tree diagrams where we don't actually put the item back into the pool. So for example, if we are, we'll just keep going and then I'll explain in a second. So this involves selecting or drawing an item, recording the results, and then not replacing the item before you perform another selection. So for example, if you had a deck of cards and you were pulling out a card and recording the suit, if in this case we would not be putting it back, which means that there's only 51 cards left and one of the suits is actually only got 12 left, so it does change the probability of it. So here we go, we have a lucky dip sale where you get a discount based on the colour of the ball you draw out of a box. If you draw a red ball, you get 10% off. If you draw a green ball, you get 25% off. And if you draw a blue ball, you get 50% off. There are 10 balls of each colour in the box. Now, when you're reading a question like this, it's really, really easy to get bogged down in the part where it says, if you draw all the way through to get 50% off. Like, that's not relevant for us because that's not what we're trying to find out. We're looking at probability right now. It might be a question where it says, what's the probability of you getting 10% off? Well, then we're looking at the red balls. But for now, we're looking at the colour of the balls. So first we're going to start by writing out the probability of getting a red, green or blue. So if there's 10 of each ball, that means in total there are 30 balls. That means there's 10 reds, 10 greens and 10 blues. Now to write that as a fraction or as a probability, we are writing it's 10 chances out of 30. And the reason I'm writing that here is because when I look at the probability here, we've simplified it down to 1/3, which is the same in this case. Then now what we need to think about is, well, if I draw a red ball and I'm looking to draw another red ball, well, there's one less red ball. There's only 9 there now, and there's also one less ball in total, so our total has dropped as well. So in this case, we would only have 9 red balls out of 29 balls in total. We would have 10 green balls still, because we haven't drawn a green ball, but still only 29 in total. And then here would be 10 blue ones with only 29 in total. And if we were to fill that all out, we can see that here we had a green ball drawn. So the red balls would still have 10, the green would have 9, and the blue would have 10 still. And in this case, we've drawn a blue, so red would have 10, green would have 10, and blue would have 9. But in each of these second cases, we've dropped the total number of balls available down to 29. So let's find the probability of a red then a green. So that is the probability of a red then a green, so this outcome here. So we're looking for the probability of 1/3 times 10 ninths. So what we get is 10 29ths, 10 out of 87. So that's our probability, and as a decimal it's 0.15. So the probability of getting a red then a green in that order is 0.15. So if we remember back to our language of probability, we would say that that's highly unlikely. Okay, well let's now look at the probability of getting 2 greens. So that is this outcome here. So in this case, like in the last video I said where you could potentially look at the outcomes and how many outcomes there are and work out the probability that way, but because the probability changes each time, we need to be very mindful of that, and we can't just use the outcomes. So the probability of getting a green and a green is 1/3 times 9 29ths, which gives us 9 87ths. So as a decimal, we get 0.103. So the next one, find the probability of 1 red and 1 blue. So 1 red is, well, let's look at our outcomes because it doesn't matter what order it's in. one red and one blue and one blue and one red. So it actually occurs twice. So what we need to do is first work out the probability of the red then the blue, which is 1/3 times 10/29, which gives us 10/87. Then we need to work out the outcome of getting a blue then a red. So that's 1/3 times 10/29, again is 10/87. So our final probability of a one red and one blue is 10/87 plus 10/87, which equals 20/87. And as a decimal, that is 0.230. Now, the reason that I know that I've got two outcomes, because it doesn't say one red then one blue, it simply says one red and one blue, so it doesn't matter the order in that case. Let's do example number 2. So a lucky dip contains 5 red gift vouchers for $50 and 5 green gift vouchers for $5. A gift voucher is drawn and the customer keeps it. So initially we have 5 out of 10 gift cards are worth $50 or they're red, and 5 out of 10 gift cards are green or worth $5. Now, if someone draws out a red one or a $50 one, that means there's one less red one left to draw. But it also means there's one less gift card in the whole entire set, so it also drops the probability again. But here we still have 5 green ones. If we've drawn just one red one, we've still got 5 green ones, but only 9 in total because there's 5 green ones and 4 red ones. Now, this arm here should add up to our denominator, which is 9. So 4 plus 5 is 9, and that's how we know we are accurate in that as well. So, I just said it without the lines. But find the probability that both customers draw $50. Okay, so that's 2 red ones. So that's only this one occurring here, which is going to be 5/10 times 4/9. And this gives us a probability of 20/90. And that, if you're leaving that as a fraction, remember we would simplify that down to 2/9. But in this case, we'll leave it as a decimal, which is 0.22. Okay, so let's do another one. This time I'm going to get you to do it. You're going to pause it, come back and do it on your own. But what we're looking for is customer 1 draws a $50, so that's red, and customer 2 draws $5, which is green. So I want you to pause this and work out the probability of getting a red and then a green, and then come back. Okay, so hopefully you wrote down probability of RG equals 5/10, because we got 5/10 chances, times 5/9, which gives us a probability of 25/90. And if we work that out as a decimal, we get 0.28. Fantastic, guys. Remember, if you have any questions, you make sure you ask. Otherwise, that is it for probabilities. So we will see you in the next topic. Thanks, guys.